Hello, everyone. Can you hear me?
Yes.
Okay. How are you all doing?
Wonderful. How are you today?
Good, good. Thank you. So we begin from where we stopped, and then last night, and then we finish up this topic of data presentation. Now, and I'm sure you must have seen that the homework, I've created the two homework, and like I noted, I extended the due date to Wednesday next week. So you can now begin working on those. So let's start. Now, tonight, like I said, we finish up where we stopped yesterday. I have to close some pages. I have so many pages open. My goodness. All right, let's see. Let me close all these pages. Okay. Close this. Good. What else? This one. I want to close this one as well. Minimize this. All right. Let me share my screen of what we have today. Can you see it on the screen?
Yes.
Good. So yesterday we did frequency polygon, histogram, bar charts, and cumulative frequency graph, among other things we did yesterday. The frequency distribution table. Now tonight we continue. Next graph we'll be drawing is called a StemandLeaf plot. The StemandLeaf plot. Now in the StemandLeaf plot, instead of drawing the graph, we actually plot the data values. So we return them the way they are, instead of summarizing them with a graph. So we just give put the numbers the way they are. But before we can do that, we have to first of all arrange them in order, ascending order of magnitude. That means from the smallest to the largest. Then we can now have made a chart. Let's use an example to do this. It says here, the Cornell Lab of ornithology. I think this word ornithology has to do with birds, right? Those that study birds. They hold an annual Christmas bird count in which bird watchers at various locations around the country see how many different species they can spot. Now, here are some of the counts. They reported in Texas in 1999 events. So these are the 228 species. Hope I have everything here. Okay, I hope so. Well, these are the species they see. It says, create a StemandLeaf plot to represent this data. Then write a brief description of this data. Okay. Now, like I mentioned, the first thing you do is to put them in order. But before once you put them in order, you can now be able to draw the charts. Give me 1 minute, just 1 minute. Yep. Put them in order from smallest to largest. So that's what I did here, put them in order. Now, next is to identify your stem and your leaf. So let's starting with the first number we have here. I'm going to move this to the next page so that we have enough room for this. So now I've arranged them in order from smallest to largest. Next is to identify the stem and the leaves. Suppose we use this number, 152, which is the smallest. For 152, I'm going to make it big. Okay. Now, the leaf is always the number at the last digit. So this is your leaf right here. This is your leaf. The last number here is digit. Last digit is your leaf. So it's your leaf right there. Leaf. Now, the other number, like 15 is 15 is the stem. So the stem will be this one here is the stem. Okay. So that this is your stem. This will become your stem right there. So the last digit is the leaf. The first digits. It can be 1 digit or 2 digits or 3 digits. Become your stem. But always remember that the last digit is your leaf. With that, first of all, we arrange them in order from smallest to largest. We identify which part is the stem because there are 3 digits in each of them. So the first 2 digits become our stem. The last digit is our leaf. Now we can make our stem and leaf plot. So we can now draw the diagram, stem and leaf diagram. The stem.
Would it be the same way if it was 4 numbers?
Or if there are 4 numbers, that's a good question. Suppose we have 4 numbers here. Let's say we have 1, 5, 4, 3, 2, or even 3, 3, 3, 5. Like before, the last digit is your leaf, right there. Mm-hmm. Leaf. And your stem will be the first 3 digits, which is this, which are this one here, this ones. Your stem. Oops, I missed it. I'm gonna move it all the way down. That's your stem right here. See? So the last digit is your leaf. The other ones are the stem.
Basically, just the remainder numbers, except for the last number, is your stem.
Yes.
Okay. No matter how many numbers it is.
Yeah. Your leaf is the last digit.
Okay.
So now we can now make our stem and leaf. Okay. Do I have people still? You can still the screen, right? It's changed on my side. Can you still see my screen?
Yes.
Good. So now we can now put all our stems here. Look at the first 2 digits from each of these. This is first 2 digits here is 15. So you have 15, 15, 15, 15, 15, right?
Always organize smallest to largest, right?
Yes. So that because if you don't arrange them, you will get a stem and leaf plot, but it will be scattered. That means you have to start arranging them again. So the best thing is to arrange them at the beginning so that you don't have to do double work, you know. Right. So that means you can see that it goes from 50. If you look at only the first 2 digits, that means this number goes from 15 to 22. If you're looking only at the first 2 digits for your stem. So we have 15 here, 16, 17,
18 and 20.
18. Now we don't have 19, right? But right. you have to count it anyway because it will help you to identify any pattern on the stem and leaf plots. 19.
So because we don't have 19, so would 19 be 0? We don't put anything in there, but we still count it?
You have to put it there, but you don't put any number there. So that way you can know if there's a pattern or an outlier. We're going to do outlier tonight, so you can see what I mean by that. Then we have 20. We don't have 21, right? But we have 22. So you still have to put 21 and 22. Now for 15, we have 152. So 152. 153. There are 2 of them, right? 2, 153. So 3, 3. So that means 152, 153, 153. See? To show those 2 numbers.
I'm gonna say that again.
This means 152,
right.
153, 153 again, because we have two of them here. Okay, got it?
Right, I got you.
Okay, good. The next one is 156 and 157. 156.
Oh, it's going to stay all in one row?
Yeah. Yep. 157. Now that's it for 150. So there's no more 150 something, right? So next thing we have 160, right? So we go over
Right.
to this side.
And we just
Yeah.
put 0.
One, no, say it again. Yeah, 0, exactly. 0, two of them, right? 0,
Mhm.
0,
0,
then
2,
2,
2,
2,
2,
3,
3,
6,
6,
6,
and 7.
7.
7. See? So I'm glad you are getting the point now. Next is 175 and 175 is second for 17. Oh, excuse me, I put something. Okay, got 175, right?
Yeah.
177, 178. Okay, that's it, right?
Uh-huh.
Next is 181, 183,
182, 83, 6.
186. Yep. Now for 119, we don't have nothing there, so just leave it the way it is. Oh, excuse me. This always happens. It's just formatting issues. Well, I fixed it. Okay. Okay. Nothing here. But we have 206, right?
2, 6.
So 26 and 6.
Twice.
What, do we have 5? No, we don't.
No.
Then we have next
Not
is
21.
228, right?
Right.
28, the last one. So that's our StemandLeaf plot right there. See? That's a StemandLeaf plot. Now, how do you explain this? Now, if you eventually we'll come to this when we try to describe the shape of distribution. I will show you this. But now, for now, you can see that according to this display, the bird watchers spotted a minimum of 152 species. See, 152 is the smallest. So 152 species and the maximum of 228 species during that season. Also, between 152 species and 180, most of the species are concentrated here. You can see that, right? Can you see it?
Yeah.
Most of the birds, these species are concentrated on this side. Am I right? Am I right or wrong? Can you see my hand, my cursor moving?
You're right.
Yeah.
Yes.
So most of the species are concentrated. So this means that between 152 species and 186 species of the birds were observed or spotted by majority of the bird watchers. Now, does anybody have a question for me on this?
Okay,
No.
so like would you have the 19 and the 21,
Oh yeah,
you
this
just
one,
don't put anything there?
this one are standing out. See, there's no number here.
Right,
No, so this
right.
one,
and
they're
there's no
they're
number for
outliers.
21.
They're outliers. See, we have two outliers here. These two numbers, this one and this one, because of these spaces, these two spaces, they are standing out. We call them outliers because they are
Okay.
standing out from the rest of the group. You can have an idea of what an outlier is if, for example, let's say that we have in a neighborhood where the people that live there are low income people, right? But you have a millionaire living there. That millionaire becomes an outlier. So that will give you an idea of what an outlier is. We're going to come to that eventually, but I want you to understand this concept of StemandLeaf Plot because I think I have it in your homework too. Yes, I have it for my homework. Any other question?
No.
Okay. Now, suppose we have an example like this one where we have two numbers each. So you say an outpatient testing center. The number of cardiograms performed each day for 20 days are shown here. It said to construct a StemandLeaf plot to represent this data and then explain a result. Now, again, you put them in order from smallest to largest. Now, the smallest number here is 2. But when you look at this, you see that each of them have 2 digits, right? Am I right or wrong?
You're right.
Yeah.
So for these 2, I'm going to use 02 to represent it, to show that, to make it 2 digits. Like, of course, you know that 02 also means 2. Am I right?
Okay.
Yes.
So now, under this 02, let's find our stem. Remember, I told you that the stem, the leaf is always the last digit. The last digit. So in this case, this is our leaf. I'm going to type this in down here. So I'm going to type stem and stem so I won't mess it up. Okay, a little bit. I'm going to type leaf here. Leaf. So our leaf is right here. The last digits, like before, is our leaf. Here, 2. And our stem is the other digits. See, this one here is stem. So assuming that I have, I picked a different number, stem and leaf, and the number I picked is, let's say 13, right? In that case, our stem will become, this one here, the one is our stem, and our leaf will be this one. See? Now I'm going to leave this one. This will be a classwork for tonight. So I'm going to post it for classwork 3. I have not graded the classwork. I'll grade them this weekend. So I have shown you the stem and the leaf for each of these. I have gotten you started. Now I will paste this after we finish the class, so that when you go to classwork 3, you can work it on paper if you like. Take a photo of it after you finish and upload it under classwork 3. Okay?
Okay.
I have a question. When you say explain your results, what does that mean?
So like I will use this example. You look at what you have here.
Oh,
can see that-
to show the example how we got it. Oh, that's how you explain it.
No. The result. Let me give you an example. Okay. Now, to explain what this data tells you, that's what it means. For example, this one tells us that the lowest amount of species they observed is 152, right?
Yeah.
And the largest amount is 228. Am I right? So during that season, the bird watcher spotted a minimum of 152 species and a maximum of 228 species. That's one way of interpreting it. Or you can also look at, when you look at this data, you can see that most of them are concentrated here. So you can say that during that season, the bird watchers that between 152 to 186 species of birds were spotted by majority of the bird watchers. So it depends on the data you are using. In this case, we are using a outpatient testing center. So first of all, you make a chart, then look at the chart. What does that chart tells you about the data? That's what I mean by explaining your results. Okay. All right. Let's see. We have the next chart we are going to do is the pie chart. So in a pie chart, it is a circular graph. In a circular graph that you have it divided into sectors. Now each sector represents the frequency or the size or the count for each particular data point or data set, group. Now, how do we do it? Now, there are 2 ways you can do it. You can draw it manually with pencil and pen, paper. If I want to do that, then you have to have, there's a theory you have in mind. That theory is that the angle sum of a circle equals 360 degrees. So with that, you can now make a table of values. Get your percentages and frequency, relative frequency, which we did yesterday, and then use a protractor. Let me show you how a protractor looks. I'm sure some of you must have forgotten how it looks like. Give me 1 minute. I'm going to show you how a protractor looks like. See if let me see if you can remember. Yeah. If you can remember this protractor, it's gonna be like this. The images of protractor. Yeah, I think you must have, this already. Okay. Now, where are we? Where are we? I'm looking for our screen. So you can see protractor. If you see, you remember this from high school?
Yes.
So after you make your tables, then use your protractor to measure the degrees, angles, and then draw. Now, but for this class, we'll be using Excel to construct our pie chart to give you the same result. So to do that, we need to put the table the right way. It says here, the table below shows the number of pounds in millions of each snack food eaten during Super Bowl. And it says, construct a pie chart to present this data and then explain your results. So the first thing is to make our table of values. You have it here, but you have to put it the right way so that you can paste it in, copy and paste it in Excel. So I have this snack, type of snack, that's the type. Then the pounds consumed, amount consumed. Amount consumed in pounds, during Super Bowl. So I'm gonna adjust this. First one, I have potato chips. How many pounds they are consumed? We have 11.2 pounds. Then we have tortilla chips. We have 8.2 pounds. So we got pretzels. So we got 4.3 pounds. Then popcorn. And we got 3.8 pounds. We got snack nuts. Okay, is 2.5 pounds. Consumed. So now we can put this in Excel. I have this. I think I have it in Excel already, but you can just copy it from here and go to Excel. I have my Excel open. It's gonna be somewhere. So I'm gonna I'm gonna paste it here. Okay. I'm gonna move this. Snack consumed. So now I have it here now. Now to draw the it says here to, let me see. It says construct a pie chart. So to construct a pie chart on this, all you have to do is to highlight the names and this amount consumed. Can you see my cursor here? Can you see it at the top left?
Yes.
Yes.
You click on that, then you choose the pie graph. It's right here, the circle graph. So I usually choose this one. Choose this one. You can choose any type, but this is one and this one you can now, it's in here. You can now choose to put these numbers in. You choose a one that have numbers on them, like this one has numbers. So it will automatically put the percent, calculate the percent. It will measure it, calculate the percent and the degrees. Everything is there. And then from here, you can now write your interpretation. Let me say, pie chart for Super Bowl data. Okay, so for snack data, right? Snack data. So now you have it here. You can see that according to, now you have it in Excel. Now next thing is to move it to the question. As this is a project, just click on this space, copy it, Control C, copies it. Go to your Word document where the equation is located and paste it under it right here. Control V, you paste it still. Now I can make it bigger if you like, So you can see it, right?
Yes.
Now, according to this graph, this pie graph, you can see that 8% of the snacks consumed are potato chips, 27% are tortilla, different types. So if you have a business, a grocery store, so during Super Bowl, you know automatically that you should stock up more of potato chips and tortilla chips and less of popcorn. Am I right? Or wrong? What do you say? Am I right or wrong?
Right.
So this can show you how you can make decisions based using a statistical data. So according to this graph, majority of the snacks consumed are potato chips and tortilla chips, but less of popcorn and snack nuts. So that's your time series pie graph right there. Questions? Any questions? Okay, no questions.
Can you
Good.
go back up? Can you go back up some?
Up here, like here?
Yeah, I just need to put those numbers in.
Okay. Done?
I got two more.
Two more, okay.
Okay, thank you.
You're welcome. Now, next chart, which is the last chart we'll be doing tonight, is the time series graph. This graph, you see it all the time. As a matter of fact, I bring it up. Time series graph. Now, a time series graph, we use it to represent data sets that occurs over a specific time period. Things like unemployment statistics, output, production output in an industry, and so on and so forth. So we use it to represent that then. Now, a good example is the one that we have here. Say that the table lists number of cellular phone subscribers for the years 1998 to 2008. So this kind of graph help us to get to see the trend of of event. So now it says for this data set, number of cell phone subscribers between the year 1998 to 2008 are shown on this table. You can see the year and subscribers. Now, this question says, construct a time series chart for this number of cellular phone subscribers, and then, of course, you have to interpret it. Now, to do that, all we need is to copy this Okay. Control C, copy this, go to Excel, and then paste it.
You say what's the name of this chart again?
You mean the graph?
Yeah.
You mean the graph? Do you mean the name of the graph?
Time series graph.
Time series graph, yes. Have it here. Now, remember, you can always draw a graph with a paper and pencil. You know, paper and pencil, you can always draw it. But you know, since we're now living in the world of technology, it's good to learn how to do it with technology as well. If you remember your graph, you make your x-axis, and y-axis. If you still remember that, and then your y-axis and x-axis. This one is the x-axis or y-axis. So, and then this x-axis can be year. You can use year if you like, and then number of subscribers on the y-axis for x. So, but for this class, we are using Excel for that. So you just copy it and paste it in your Excel, and then where is my Excel? Right here, it should be here. Good. Now, next thing is to put the graph itself. You highlight numbers, years, insert, use the correct graph, line graph. If you use this, it doesn't show me the trend. See, if I use this, this graph doesn't work. So I'm going to delete this graph. Not good for this data set. So I try a different one, which might be, which is not good. I can use this one, the SY bubble charts. So I can use the one that have a line on it. You can see that it gave me the graph right away. See? So time series graph, yes. Time series graph. Okay, graph for cell phone, phone subscribers data. So you have the graph here. Now I just put the axis. Say put the axis. Put the axis. All you have to click on this plus sign to give it the options. Put axis. So you see the axis title right here. See here, this one is the year. The year. Then on this side, it types the subscribers. Subscribers in millions. So you have your graph right there. And you can copy it, click at the top here, then do Control C, then go to your Word document if this is a project. Under it, you can paste it. So I'm gonna remove all this. So I'm gonna paste it here. And then remove all this. So we can have our graph. So I can bring it up, and I can expand it if you want. According to this graph, you can see that from 1998 to 2008, it's going up. More people are getting cell phones. As a matter of fact, these days, I don't know how many people still have landline in their house. Almost everybody has this cell phone. And the one that we used to see before in every street, the pay phones that we used to see in every street, I don't see them anymore. So according to this time series, number of subscribers has been increasing since 1998. And this keep going up. So it shows you the trend of the event. Okay. Any question?
No.
Can I see what graph you used again?
Even in the
Like
Excel?
when you clicked on it,
Even in the
when
Excel?
you went to insert, yes.
Yeah, this is one I used. I'm gonna show you now in a minute. This is the one I used. This is the this one here. See, it should,
Okay, the one
yeah,
per chart.
XY, exactly.
Okay.
Now we have finished the data presentation that we need to cover for this particular class. We have 5 minutes left, actually 4 minutes. So I'm gonna end it here, end this session, then wait for 10 minutes, log back in so that we can complete this next session that we have. So I'll end this one here and just wait for 10 minutes, log back in. So we finish up with the shape of distribution. Okay.
Okay,
Okay.
all right,
I see you here back here in 10 minutes.
10 minutes.
Yeah, 10 minutes it is.
I had a question before we go.
Mhm.
So you see how we have these lines? When I did my classwork, my polygon, I can't get it. I can either do the scatter and get the points, or I can do the line. I can't get the points and the line. Could you show me what you did?
The points are given. This is the points right here.
No, that's not what I mean. I mean on the graph. Like I was able to either, if you could scroll back down to the graph.
This one here.
Yeah, just for example, when I did the polygon, I can get it with just the bullet points without the line connecting, or I can get it to where it's showing the line, but it doesn't like highlight the bullet points on the graph. I can't get it to where it shows the line and the plots.
So let's say that this is the you want to draw a bar graph. Is that what you mean? Bar graph.
No,
right?
Hold on.
Frequency polygon.
I mean what was the homework? Was the homework the the classwork was the histogram or polygon?
You have to check.
It was a histogram.
Or histogram. When you draw it first, maybe I'll show you in the next after we finish next session, because we have only 2 minutes left now.
All right.
It won't be enough to show you. Yeah.
Okay.
I will show you after that session. Yeah.
Okay.
All right.